Let us evaluate the integral of cosecant to the power of 3 of x when dealing with an integral of cosecant that has an exponent of an odd number. Firstly, you would first need to factor out 1 cosecant squared of x, making this the integral of cosecant of x multiplied by the factored out cosecant squared of x dx. And when dealing with cases like this, you would want to group up the factored out term to the dx. This is because our next step here would be to involve an integration by parts. Just a quick formula for this. The integral of u multiplied by dv would be equal to u multiplied by v minus the integral of v multiplied by du. Where in this case here, our u here would be cosecant x and dv would be cosecant squared of x dx. So let us assign that. U here would be cosecant of x, and next step would be to take the derivative, which is du. The derivative of cosecant of x would be equal to negative cosecant of x multiplied by cotangent of x dx. Next up would be the dv, which is this one. And we need to get rid of the d here, which means to integrate the integral of cosecant squared of x dx would be equal to negative cotangent of x. Just a reminder, the derivative of cotangent of x would be equal to negative cosecant squared of x dx. In this case, since our cosecant squared of x here is positive, make the sign here the opposite. So it would be negative cotangent of x. Now that we have our values here, we can now substitute it using our formula for integration by parts. First up would be the multiplication between u and v. U here would be cosecant of x multiplied by v, which is equal to negative cotangent of x, minus the integral of v, which is, again, negative cotangent of x multiplied by du, which is this value right here. Next step would be to simplify. We can put the negative sign in here, which makes this negative cosecant of x multiplied by cotangent of x minus the integral of, you can see here that we have both cotangent of x, which makes this cotangent squared of x, and we have two negative signs here which we will multiply, makes it a positive sign, and copy the rest, which is cosecant of x dx. And the next step would be to focus on the part that has the integral, because in our case here, there is no integral, so it is now simplified as it is. Focusing on here, we must focus on cotangent squared of x. Know the identity of cotangent squared of x be equal to cosecant squared of x minus 1. In our case, we can directly substitute this one. Cotangent squared of x and copy the rest first. Next step would be to distribute our cosecant x among the parentheses. Cosecant squared of x multiplied by cosecant of x would be cosecant cube of x minus 1 multiplied by this would be the same. which is cosecant of x of dx. Before we would need to move on, we can split this integral into two parts and distribute also the dx while in there. So this would be cosecant cube of x dx. And since what we have here would be a negative and negative sign, multiplying this, which makes it positive, integral of cosecant of x dx. At this point, whenever you see a term here that is similar to our original problem, such as this, the integral of cosecant cube of x dx, same as our problem right here, we would need to get rid of this one because it will take us for a loop again. Notice that the integral of cosecant cube of x is actually equal to all of this one because we had just manipulated this to get this value. And with that knowledge, we can equate this to each other, Doing that, this would be the integral of cosecant cube of x dx be equal to this one right here. And our objective for equating this two would be to get rid of the cosecant cube of x here. Since what we have here is a negative, add both sides an integral of cosecant cube of x dx. By that, this would be equal to 0. And this would be equal to 2 integral of cosecant cube of x dx. This is because it's just the same term and it is addition, so just add the coefficients and copy what is rest here. And you can see here that we would need to get rid of the two variable here because what we only need would be a singular integral variable. And by that, we would need to divide both sides by 2 or multiply both sides by 1/2 if that's what you want. One half here and 2 would cancel, and we can distribute 1/2 among these two later on. Our simplified term here would be now the integral of cosecant cube of x dx be equal to, wait, this should be negative. I forgot to put the negative sign. And multiply 1/2 by the first term first, which is negative 1/2 multiplied by cosecant of x, cotangent of x, plus 1/2 the integral of cosecant of x dx. You can see here, this is already simplified, and our last step would be to integrate the cosecant of x. But in this video, I will not be putting the full step of it because it is quite long. And instead, I will just put the full answer regarding that. And the integral of cosecant of x dx would be actually equal to the natural log of the absolute value of cosecant of x minus cotangent of x plus c. This is the integral of cosecant of x. And now our final answer regarding the integral of cosecant cube of x would be equal to negative 1/2 cosecant of x cotangent of x plus 1/2 multiplied by the natural log of the absolute value of cosecant of x minus cotangent of x plus the constant of integration.